think he is.
Oh, you are.
Just recording. Yep. All right, class, let's start here. So I do want to just to mention something real quickly here. The one-to-one correspondence is at 2327?
Yeah, I think so.
Okay. So one-to-one correspondence. That is something you guys saw all the way in Algebra 2. And you probably just saw it just for a brief moment here.
Does not even ring a bell.
Does not ring a bell. Okay, let's talk about it then here. So one-to-one correspondence means just a little part right here. So maybe just a quick explanation of it. This would be a one-to-one correspondence of, let's say this is 2x plus 3. So a unique x also gives you a unique y, right? And a unique y gives you a unique x. There's never a time you have any repeating of your domain or your range. There's never a repeat. You guys remember those?
That's a definition of a function.
Ooh, yeah, it's we'll get there. We'll get there. So definition of function means that the x's don't repeat themselves. The y's can. Okay. A one-to-one function says the x's nor the y's repeat themselves. So in this case, would this be a one-to-one function?
Yeah.
Let's back up here.
I thought you were saying will this be a function?
I was going to have that. You read my mind.
I anticipated.
Is this a function?
See, your
Yes.
self-deprecation you just take it off.
I didn't mean self-deprecate. I anticipated the wrong question.
It's a fact. So it's a fact of what he did.
Yeah, it's a fact of what was going
But
on
if
in my
you
brain.
said that, then it would be something.
You guys are all lucky you get to have an insight into my brain.
Okay, so it is a function, correct? It is a one-to-one function. No. Okay, so now what is a one-to-one function? What does it give us? A one-to-one function says this. If I were to take the inverse of this function, of this guy, it would still be a function. Okay, good? So one-to-one function means if I do the inverse is a function. So now the question comes up over here. If I take so this would be a function, right? Inverse. And we know how we do inverses, right? Just real quick here. We switch our x's and y's. And we just start solving for the y again, right? So subtract 3, divide by 2, and there's my inverse function right there. Okay, we're good there. Go back the other way here. Yes, obviously here, that is not a one-to-one function, therefore the inverse will not be a function. We're good? And it kind of makes sense, right? Because remember, to be a function, the x's can't repeat themselves. But if you have repeating y's and you switch them, now you have repeating x's, right, on your hands. And then we have a little trick question here. Can I make this into a one-to-one function? Yeah, if you cut the side that's repeating the y's, yeah, so you actually two different ways. We could either keep all the negative x's right here, or we can keep the positive x's. So if I restrict my domain, it's called. If I restrict my domain, just saying, okay, I'm only going to deal with that. Ooh, now is that a one-to-one function? Yes. Does it have an inverse? Yes. Is that inverse also a function? What is that inverse function? Nope.
Oh, wait, negative x or x squared.
Absolutely. Square root of x. There is my inverse function right there. So notice the square root of x does not have a negative side to it. That's exactly why right there. Because it would be repeating itself. Can you actually just have inverses only? Just like, hey, I want an inverse of this. Absolutely. Let's do this real quick here, just for completion's sake. So can I find an inverse of this function? Yeah. Correct. Yeah, you just take the y's, move them into x's. So 0, 0, 1, 1, 2, 4. Also, we take negative 1, 1, negative 2, 4. And yeah, there's my, oh, sorry, 2, negative 4. So thanks. Right? Negative 2. 4, negative 2. Sorry, yeah.
Yeah.
There you go. Thank you so much. Okay, boom, there it is. Are we good? So yeah, we can have inverses, except those inverses are not functions. Sadie, are we good with that?
Yeah.
Sweet.
feel like the rest of the stuff, when I had questions in the homework, was just because I couldn't remember, like, I know it, but I can't remember, like, how the identities work or what the transformations do. Why didn't I repeat it? I'm having trouble using, like, the online thing or finding where the information I want is in the textbook. Because I can see,
Control F.
yes, I did that and found it, and I just did it. I would rather open by section.
Uh-huh. And I don't know, is the review exercises by section or not really?
Yeah, the
Or
review
they're just kinda, they're
exercise is
just
just
throwing,
problems, and then you have to go back to the chapter, and I wasn't quite sure what all it was in the chapter.
gotcha, okay.
I can also review, I probably just look at my token.
Yeah, let's see, I mean, the page before, 119, it does have those key concepts. So this is and then it kind of gives you the highlights of, not the, but the titles of each section. Right, so 1.1, kind of easier to work backwards. 1.5, we covered exponential log functions, right? 1.4 was all about inverse functions. Going backwards on trig functions was 1.3. Basic classes of functions would be 1.2, and then just a review of function itself, just the definition of it was 1.1. That might give you a help there.
Yeah.
Okay. Are we good? Are we ready to move on?
Oh, also, one other thing,
Yeah.
120 or 298 doesn't have answers, so if, I don't know if you want us to have answers to that, I'm just confusing.
Yeah, I got
Or you can just
answers,
write it.
and where did I put them? I put them on a slide, except I'm not using a slide. I think I erased it. So yeah, I'll give you guys the answers to those.
Thank you.
Sure. Okay. Jamming. I'm glad. How's the review going though? Review of chapter 1 as a whole. Easy, you guys remember? Like, oh yeah, I remember that stuff. Okay.
I don't believe you.
I
So-
don't know what you're talking about. It's going in that he like looked at what he
How's
wrote
my
down and
He's
and
getting ready
to begin preparing to send down. Yeah.
See, I don't even need to do self-deprecate. They do it for me. Perfect. My plan has worked. The workaround.
You played
You played 2D Minecraft yesterday.
only because you wanted me to buy it. So terrible.
I don't find.
Okay, go. Let's go. 2.2, the limit of a function. We're going to skip 2.1. 2.1 was just a sort of intro to calculus, but I figured when we get to chapter 3, that'd be the easiest way to do it. And we had that video with Professor Dave. Remember that?
Yeah.
Oh, yeah.
Professor Dave. He was talking about there's two different types of calculus. One is called differential calculus. We take derivatives. That's be one side. And we start to do integral calculus, which would take the exact opposite direction. So those are two sort of pieces. And that's kind of what 2.1 is talking about, but we'll talk about it later. So first things first, let's define what a limit is first, and then we'll go from it. Limit has nothing to, well, it has a few things to do with the graph. But when you check a limit of the function, you're talking about what's happening as you approach from the right-hand side and what happens if you approach from the left-hand side. That's what you're talking about. And if those numbers are the same, the calculation gives you the limit of the function. We good? So it's a calculation thing. Okay, so let me write it out for you. And so this is the way the limit is. Ready? It says limit as x goes to a from the left side is called L, and the limit as x goes to a from the right side of this function is L. Then the limit, I think it's a lowercase L. Yeah, it's a lowercase L. The limit as x goes to a of f of x is L. Good there. Boom, boom, boom. So if the left side matches the right side, we got ourselves what we want. And the book starts off using tables and then switches to graphs. I'm going to do the exact opposite. Let's go graphs, then we switch to tables. It makes so much more sense to do it that way.
Wait, so I have a question.
Yep.
For the x
to a minus and the X to a plus, is that just left versus right?
Sure. Approaching. Thank you. Approaching from left side. This would be approaching.
Oh,
Is it
it's like negative and plus.
Yeah, 0?
From right
And
side.
it is so it's capital.
It's a negative and a plus.
Wait, so
It's a negative and a plus. So kind of funny. It does not mean inverse. Does not mean, let's see what negative signs are used for. Negative sign does not mean reciprocal. It means approaching from the left side.
So from the left towards the center?
No, towards whatever A is.
Oh, okay.
So let's talk about it as we go. So let me give you my first graph, and then from there, like, oh yeah, that makes sense now. And then we'll go from there. Okay.
Oh, is that for the approaching from the right, is that a lowercase L?
Because they're both capital.
Well, the one that approaching from the right is a little more sturdy.
Oh, sorry, yeah, no, it should have been, just, it doesn't really matter,
I
just
remember
any kind of
you
L.
saying like uppercase is lowercase the left side.
Oh yeah, so whenever we would do limit, Lim.
Oh,
You've seen it as capital sometimes, but
We're talking about, okay, the L and.
The L and the L, yeah.
Okay.
okay, first example problem, let's go. I got this little graph right here, fun graph. I got a little dot there. My dot is here. So if you guys can graph this guy, let's go with, let's say 3. And let's say this is 2x. Or we'll start off.
What?
And fail, then we go from there. Okay, are we good to go? So part A is give me the limit as x approaches 3, not 2. 3 from the left side of this function. Starts off slow. I think calculus is just so easy in the sense it's like, oh yeah, that makes so much logical sense, right? But just to discover something. Is that the same thing? Whenever we do other things in life, to discover something takes a lot more effort than actually just doing the process.
Right. So we're just like plugging in 3 for x in the function.
That'd be good. That's the first. So this is approaching. And so let's see, what is this little dot right here? So if you plug in the 3, as Eli said, what do we get here? We get 10, right? And this guy I'm going to put at 5. Is that okay? 5. Okay, are we good there? My graph is kind of gone to scale. So what is the limit as x approaches 3 from the left-hand side? So if you're on this little line right here traveling up, and you're not stepping into this little piece here, right? You're just approaching. So you're at 2.8. Then you're at 2.9. Then you're at 2.99. Then you're at 2.9999999. What do those numbers look like? Are they kind of getting closer to 10? Closer to 5? What are they doing? Closer to 10. We're good. Intuitively speaking, we say like that makes sense, right?
Yeah.
So if you did a chart, let's see, I guess I do go back to chart. 2.8, 2.9, 2.99, 2.999.
As you get closer to 3, it's smaller differences.
Yeah, but as far as this function goes, though,
It will never hit 10.
it won't hit 10. So you're looking at what, 9.9, right? 9.99, 9.999999. I mean, you're pretty close to that, right? Each time you do that. Okay. B, limit as x approaches 3 from the right-hand side. Now your stickman is walking right here. So as you think about it here, you start off at 4, 3.5, 3.1, 3.01, 3.00001. Everybody okay with intuitively speaking, that's 10 again? Okay, so if these guys both of these guys match, then we have the limit as x goes to 3 is also 10. We good? So the C is just a calculation based upon A and B. Ah, good, good. So then D is going to be like this. What is f of 3 though?
Your calculator can't point to the exact equation.
It probably can.
Oh, sorry. Yeah, no, go for it. Yeah, that's right. F of 3, if you're going to use this function, it would be 10, right?
Yeah.
But our graph, the way our graph is set up, there's one little dot, it's not 10, right? So this function is, are we okay with 5? Because that's what our function is. Right, that little dot at 3, right, the dot at 3 has a value of 5. We're good? That's the way I just drew it. We're good? There's nothing special with the graph. The way I drew it was...
Wait, so is f of 3 not, like, f of x is not 2x plus 4? It has to be a different function.
Sure. So let me define the function here. How about this? So the function that we're using is this right here. So I should have done that here. So here's our little function.
Oh. Right.
Is that okay now?
That's why the other one is not.
Second? Yeah, the dot is not actually, on 10. Okay. Sweet. Okay. Eli had a question of what happens if they're not the same, so we'll take a look at that one here. We're good? Now ready for example 2? Boom. Again, getting started slowly. Gotta get the way here. So I'm not going to define the function anymore here. How's this? I'm just going to say, here's my graph. Go here. That's going to be, let's do 2 this time.
Oh. That's what those graph. Oh.
And I could put a little closed dot. I could put it anywhere, right? I just put it there.
Yeah, I've seen these before. Thought, what the heck are those? On timelines, on like number lines, yeah, we did open dot closed dot. We didn't do it on like graphs.
Yeah, it's like,
Yeah, there.
Oh. I read that. Mostly because Mr. Taylor told us not to read the textbook. The textbook was bad and only for the question.
Which textbook? This one?
that text is the one I used right there.
Pre-calculus one? Pre-calculus one?
Oh, no, the different one.
You didn't
Okay.
use that one?
We used a different pre-calculus one. Remember, it was shark blue.
I think it's that one.
No,
Front
no,
of
that one's
is
very
dark
cool on the
blue.
front. That one is fine.
It was fine to me. He just said, Mr. Taylor just said specifically, do not read the like examples or do not read the lessons because they're bad.
Gotcha. Okay.
I was all, okay. Don't look at me. I don't know what he was saying.
All right, let's go with it here. So I need limit as x approaches 2 from the left-hand side. What do you guys say? I go with 3. Are we good? If we're on the left-hand side of 2, right? We're on this side. So our stick man is right here. Stick man's walking, and he stops just shy of where we're at.
Do you remember how the left and right approaching part works?
So if you are from the left-hand side, you go from negative infinity, and you're kind of just getting closer and closer from this side.
So it's saying, if you're or start on the left side, or like going left to right, and then you stop at the 2.
Stop
on the
right,
x-axis.
right before the 2. Right
Or is it
before
like
the 2.
a more of an asymptote?
He never stops though, you just keep going forever. He just goes infinitely less space.
Is it an asymptote?
It's not an asymptote, no.
It's just that like if he's walking and he just like stops there, but it doesn't stop.
Sadie, you're confusing
Never
everybody.
touches the wall.
So he's getting infinitely close to 2, right, on the x
So the
axis.
limit is 3.
So he's at 1.9, but he's at 1.99, 1.9999, right? 1.99999999, right? As he's getting closer to there, what's the y value becoming? Basically 3. We're good? Okay, Kate, was that good?
Yeah, that was good.
All right, let's go B. Answer is, we're approaching 2 from the right-hand side. It is not 3, Kate.
Zero.
It is 0. Stickman is walking this way. So from the right, notice there's 2 different graphs here, right? So as he's approaching here, Stickman gets to 0. Pretty good there. C is just a calculation. Answer is?
Do not engage.
Okay, or does not exist. So because A and B were not the same, therefore it does not exist. It's just gone.
Undefined.
It doesn't, it's not undefined, it doesn't exist.
Yeah.
No.
Yeah.
It's between not being able to define it and not being, not just not being there at all.
Yeah.
Unless we just can't define it because it's not fair enough.
I think it is defined because we have the limit.
Defined as not exist.
Yeah, we have the
Kind of like
limit.
chronology. It does technically have a definition. It just does not exist in the world of science anymore.
Okay.
It's just bad.
What is f of 2?
But
So that one, now you're concentrating on the dot itself,
Sure.
right?
Right?
Yeah, wherever that little closed dot is, that's what you're concentrating on. In this case, it's just, yeah.
Wait, so why would you close that and not close that?
Open dot means you're not at that value. That's
Oh,
the
that's
whole
the
point of
one where
open
you-
dot.
We all root for open dot.
Oh, yay.
Okay.
Close dots. We don't root for open dot.
I'm being closed off.
Okay, another
What
one.
team are you on, Katie? I don't know.
Ooh, how about a trig function here?
Oh, no.
Yay!
I should have dipped
That
down a
was a
little further.
cosine wave.
Thank you.
Are you going for a sine wave?
No, I was going for a cosine, but I want to dip down a little further. There you go. This one's too short.
That is,
Graphing.
Just say graph is not drawn to scale.
just put +1 to your cosine. And then,
Okay.
Graph is larger
just put +1, it'll move it up.
Or to show
It's up just
texture.
like by +1, so
That's
just put
different
+1.
material.
It's fine.
No, it's
No,
still,
it's not.
this is not, this does not correspond.
Well,
It
the
should have been
values
lower.
are not the same. It's the-
Graph is not non-scale, okay?
It's not, even if it.
Or you
if
put
it's
+1.
If you put +1, it's still not, it's still not how it works.
Yeah.
+1. It's
Well,
still
it doesn't have a
wrong.
little squiggle right next to it.
If you just say not drawn to scale, then it's perfect. Everything is great.
Are there no dots?
No dots.
Oh.
Are we finding the area under a curve? Or is that later? Please don't tell me.
No dot.
Here.
You guys have. Richard, why are you scared of calculus? It's so easy.
Were you calculus teacher?
Yeah, calculus is like super easy. According to this
Your
Dave,
calculus.
according to that Dave too.
According to everything in this calculation.
Just repeating what Dave told me.
Yeah, well, Dave is,
Dave is.
Dave also understands calculus. Maybe
All right,
I
let's
just-
go for it here. So think through the answers here. It should be pretty short. It should be okay here.
Wait, no, oh, that becomes
does that mean like whenever x is 0?
Is it just gonna be
So
0 and
That's
infinity?
going towards 0.
yeah, we always have to say, as x goes to 0, what's happening with the graph? So as x goes to 0, what's happening with y? So
But
Go
x
to.
goes to 0 multiple times.
No, it goes to zero.
Wait,
Good.
it doesn't have any value. The origin.
Why is the one that's changing? X only goes to 0, 1.
Good there.
It goes to
Eli.
1 and 2.
So X is only going to 0 one spot, right? It's the y-axis, right? So you guys tell me. There it is. Limit as X goes to 0 from the left-hand side. The left-hand side is this guy walking. Answer is? It's 1. Yeah, absolutely. As, Kate, we good with 1?
Yeah.
Okay, and as X goes to 0 from the right-hand side. 1. And if the two stick man shake hands at the end, we're all good to go. They could just invent it. So what is f of 0? Still 1. Yeah, absolutely. Okay, so real quick here, we're going to find out these little two pieces. If you have this, we're going to call this continuity. If you have the limit going this way, limit going this way, and it's cool, and then the function itself is there, you have yourself a continuous function. That's the definition of a continuous function. We're good there?
Okay.
Okay, can you do all 3 steps at once? I need to know limit as x goes to pi over 2 of f of x. Okay, talk to me if you're getting it. Talk to me if you're confused. We're good?
I get it, it's just.
Eli, go ahead. Talk to me. Talk through it here. Don't know.
No, I know. Does X go to pi to O?
So for E, you got to do both. You got to do from left and from right and see if they're okay.
My brain doesn't want to deal with.
Is it? Wait. Hey, isn't it 0? Yeah, it's right there. Yeah, it's right. It's right where it crosses down.
Okay, you got to find out where pi over 2 is first, right? So this is 2 pi. That is pi. So therefore this is, that's pi over 2. And is it consistent? Yeah, it's coming down, right? As x goes to pi over 2, the function goes to 0, right? From the right, it is going to from the left, therefore it is 0. We just did A and B kind of together real quick here for pi over 2.
So from now on, we won't be doing it like, so we have to do it in our, like, we're not gonna have like A, some person from block and B.
Yeah, I will say it. I'll say it, but then we want to get to E. So I'll say, okay, guys, what's the limit as it approaches from the left? 0. What's the limit as it approaches from the right? 0. Cool. Limit is 0.
I don't like 5 years.
Okay.
I do.
Okay, let's go to ones that do not exist. Yeah, we should do that now. Let's see. We're here to 45 after, right? We get to torture you that long. This is good. Love it. Okay, next step as we do these here. Let me see if yeah, we can do that. One second, guys. Oh yeah. This is... We've got to. So let's go to limit.
What is that I see on the
It
page?
says lim x.
Do you see that, Eli? The sine wave that constantly condenses into.
Clearly, they've just taken a screenshot of the Desmond graph where one of the variables has that spider ball.
Yes, so fun to watch.
Certainly not for this one.
We are in example 3.
Oh, 4. Wait. Yeah, 4.
4. Okay, so let's do this here. Let's do 4. Let's do A. Find the limit. Limit as x goes to 3. Good there? Of 3x. Or 4x. Let's do 4x so the numbers don't correspond. Okay, so now kind of think with me a little bit higher level here. You don't have a graph of this. You could make a graph in your mind of this, that's fine. But you're saying that the function 4x, is that a very continuous graph? Is that there's no breaks in it, right? There's no nothing, right? Is it like this Christopher, or is it like this? The 4x.
Angle.
Yeah.
Angle.
So what would be the limit right here then?
Well,
That's all. That's going to 3, 3 for x, and that's where it's not going to get 12.
Okay, are we good there? Uh-huh. So then the question becomes, yeah, okay, I'm going to go to infinity. Okay. So then the question becomes this. Is this a continuous graph? Or x, right? Diagonal, right? X is just x, right? It's a,
yeah.
okay.
Yeah.
That's just 3. Okay, so let's do the abstract. Here's where the proposition. Actually, I could do the property, right? Property L, a limit as x goes to a of x is. Everybody agree with A? Everybody agree with Eli? Okay. Property 1 done. Next, how about this one here? This was the easy one here. On the book, it just says 2 important properties of limits. That's what this is. Just 2 important properties.
It's 5. Oh, wait.
Everybody agreed with 5?
Y equals
Not Christopher. This is the horizontal one, right? 5 all the way across?
Keep going.
Yeah, so x.
It's just
Your screen just went flash.
Uh-huh. Yeah, it does some funny stuff here.
It's not
My
on
view is not
today.
like,
Everybody agree with 5, right? It's a constant term. It's 5 always, right? No matter x goes anywhere. X goes to 1, x goes to 0, x goes to negative 50. It's still going to be 5. So proposition number 2. No, they labeled it as I and 2. And Roman numerals here, guys. So limit as x goes to a of a. Oh, hold on. X goes to a of c, a constant term. It'll just be c. Are we good? Yeah. So the two important limits.
those are the only 2 properties that are
Yeah, for now. Yeah, I'm gonna take a look at individual graphs here in just a second.
Boxing this. If that's the only 2 properties, then
Okay.
my notes are not always very well organized, so it's kind of hard to find things sometimes.
to match. It's like my
No, my Google Drive is all.
Is like your what?
my favorite thing.
My notes, I mean, they look nice.
you look nicer than mine. You can go to the net.
I don't have a glue stick at home, so all of my papers are just stuck in the front with the glue.
It's not that hard to get some glue, or like tape, or something sticky.
But you don't reset this. No.
What is that?
Hey,
What is that, Kate?
You need to reset the envelope.
stop president. Don't stick the fork in the elbow.
Don't push the big red button.
Okay, my function. I think this is right. Yeah, f of x is 1 over x minus 2.
Okay, yep.
What is x?
But then
Yeah, what?
oh, wait, so because those are asymptotes,
Uh-huh.
it'll be undefined. Because
Ooh.
you want to actually, you never get it. No.
And here's where we get to. It's something called infinities. We could do infinities because we want to see how things go. So if it's so one-dimensional limits or one-sided limits, if it goes to infinity, you just say infinity and which infinity goes to. So it could go to positive or negative. So let's go with it. A, B, C. Uh-huh.
Yeah.
And then we'll do another one here. So A answer is from the left-hand side.
Negative infinity.
No infinity, everybody agreed?
Plug that into the x. It's just 1/0.
So here's where they go. So limits are not what happens at that place. Limits are what happens as you approach that place. That's such a conceptual difference there.
Concept or
It's so nice.
concept.
Okay, we good there? You like? Yeah, that's the like the light bulb moment when you realize like I don't care what happens at that point. I only care what happens coming to that point. All right, B, limit as x approaches 2 from the right-hand side. Answer is?
Infinity.
Yeah, positive infinity. We usually put a little plus sign to signify if it's plus or
I can
negative.
do that.
So C, answer is?
Positive and negative.
0.
It's different.
Yep.
Yeah.
Are
It'd
we
be cool
good
if that
there?
equals 0, but you know, it's
If
not
you're
really
good
like
at
5
something, 0 is it?
minus 1.
Wait, why wouldn't it be positive infinity and negative infinity?
No.
Because they went to different
Why?
spots, right? They're not going to the same spot.
So you need to find one. It was from the zero to annihilation, like, it doesn't even exist. Nothing is not.
It's a thing.
What do you mean, nothing is not a
Or
thing?
it is.
I mean,
Yeah, so it's not
nothing is
then,
nothing is an idea.
but it doesn't exist.
Nothing is, it's like black not being a color.
Black is a color.
It's a color.
Not an island.
Guys, I'm so excited for Wednesday and Friday here.
You know, I'm just saying what we should do with this.
I don't know what to do. No, you
I
can
have
use Wednesday as an excuse to your topic.
Like Kanish.
Oh!
Yeah.
Your fingernails out.
The topics
Where
are
are
fancy, Eli. Not bougie. But it's also fancy. Well, if it's fancy, then I'll just
Eli.
throw on my cardio.
You need to rent a tuxedo.
It's
so
time
good.
or money to wear a tuxedo.
I know, but
Well,
it
it's
would
cheaper
be
than
so
buying a
good. You should get
tuxedo.
like a big first.
But I don't need a tuxedo.
Oh yeah, you should buy a
You
tuxedo.
will.
Wear it to prom and your wedding and like all
I
that
don't
stuff.
even-
And your wedding.
You know, plan for the future, Eli.
And then you can just wear fancy clothes. You don't have to think about my wedding. Yeah, you should just be a bachelor.
I should.
I'll be sad.
It would be like that.
Just put like, I don't have very good shoes.
My parents have a friend who's a bachelor.
I can agree. He could.
Oh, I can't.
How do you know I can cook?
Oh, God. That's gross.
No, it's not.
All right, 6, all yours, go.
That's the first one.
First one's infinity, positive infinity. Second one's positive infinity.
Then it's just positive and
They matched, is that right? Because that was the whole point. If they match, then we get our answer. And I'm gonna just double check, but I'm pretty
Wait, so
sure.
they're going to the same thing. They match. So the last one was going positive, one was going negative, and you could put both. So
Correct.
this one, even though there's two things, that were.
Correct, yeah. Technically, it's still not a limit in the sense it's a number, but it's still we classified as
Wait,
that. Okay.
why is it not?
Because they're both going to.
Oh, yeah.
Why?
No, you.
Sure, she's asking another question here. When we think of limit, especially later on, we're going to think of a number that it gets to, right? You can't get to positive infinity. So
When you said
we
the-
still write it in because it's the calculation, right? If A and B are the same, it's a calculation thing. So C is going to also be that thing.
How is infinity at the same time not a number, but also a number?
Remember, because you think of infinity two different ways is what is it approaching? And the other one, what's the limit? What's the limiting factor on things?
Can't we? Infinity is weird. Infinity is
It's so
It is.
confusing.
It is.
It's sort of a number. It's like infinity.
Uh-huh.
You can get there, but at the same time, it isn't going to keep on going
You
forever.
can get there if you have a amount of time, so you can have the kind of.
I don't think you can ever get
That
there.
just doesn't work.
And then you get
I don't know.
infinity.
Hey.
I don't know if you want to experiment, but I'm pretty sure it will, yeah.
It will. Actually, that would be kind of funny.
Well,
If we murder her as a socket.
Okay, I don't think you should experiment.
yeah, don't try. The fire extinguisher's right there.
Well, no, is her,
All right, F of 3. I just still need to know F of 3.
Did I also fall from infinity to the other side? No,
Right?
Oh, because it never gets.
because it won't get there. That's not fair. Oh. What was our kind
Those are
of
asymptotes. Those are asymptotes.
Like, I need to like.
Those are
figure out
asymptotes, yeah.
something.
Uh-huh. So the value itself is
so
it.
that's what the bottom, that's an
Okay, we're good there with that. I think we have enough there to get started now.
If you put a dotted line on the graph, that just means an asymptote.
Yes, yeah. Vertical dotted line means asymptote. Okay, there's that. Let's go with 7. Let's turn our attention to your calculators and let's take a look at table values here. We good? So let's just do an easy one real quickly here. So this would be,
I've decided I'm gonna write my scores differently.
okay. All right, find the limits. And so what we want to do is we want to create a, you guys know how to create a table on your calculator.
Yeah.
I know how to get to a table, yeah, I can't do anything.
Ah,
You can
okay.
graph the table.
So go and, I know you guys have,
Statistics.
if we can do this here, go to y equals first.
You did that.
Okay, go to y equals and put in 2x minus 1.
When you go to stat pad, we'll, okay,
And I think you
Well,
can
let
plug
me
in the
clear
function
my,
2x minus 1. You put that in there already?
Yeah, and then just graph it.
And then you graph it,
enter the
And then from there you should have a table function at this point. Table set and table function.
Yeah,
Now the bad part is with the table function, you can't make this to be like this because this is what we look at limits. It's 0, 1, 0.01, or in this case, since we're going to 3, right? We're going to 3. It'll be 2.9, 2.99, 2.999, and then so on and so forth, because that's the limit.
actually, I learned how to do lists.
Okay,
Oops.
so are you good, Eli, with the calculator? Perfect, okay, so then you should have a little table set button, table set.
Yeah.
Yes, we do have a table.
Yeah, table set, go to table set, and just click, starting point is 2.9. And then you don't really care how fast it goes because you're just interested in that particular one, right? So you,
Just press enter.
yeah, press enter. And what is that? What's that going to give you? On table set, you go 2.9.
Wait, so.
Table set, I have table set up.
So you're starting.
Yeah, it says 2.9 goes to 4.8.
Yeah. So 2.9.
Oh, then it's still.
You know, you said the table difference. Just put that into one. It means how fast you go across.
Oh, wait.
I mean, yeah.
Never mind. It doesn't make sense.
Okay.
We don't have function.
I know. It's like some of those buttons, you're like, I don't know what that is. What does that do?
Like most of them.
Cool.
Okay, so real quick here, don't want to take too long with this one here. So 4.8 is what we got. So just kind of give you the visual of it, okay? Go back to table set, put in 2.99.
You changed the increment that it calculates?
Well, you have to change it each and every single time, right? Because what the calculator does is it goes every 10th, right? And then, or every 100th. So you're just interested in that piece. Uh-huh. And the next one would be, I bet you the pattern is starting. Uh-huh. So each time you increase a 9 in here, there's a little 9 that goes to there, right?
Well, you just
So-
put too many times and just turn it off and it's fine.
Uh-huh. Okay, Christopher, we're good with just sort of seeing this here. So limits are also, you could do on table. That's the whole point is, numerically speaking, you're trying to figure out what happens as it approaches one single number. I don't care what happens at 3, right? I care what happens as you get to 2.9999999. Okay, we're good then? So there's your table. So by table, I know this guy is 5. We're good? Okay. The only problem is we got to be careful. Here's the other problem here. This is A. Let's go with B. Oh, let's see. Hold on. I guess we can do that. Yeah, let's see. I'm going to go with limit as x goes to 0 of sine x over x. So real quick here. So first things first is, and then we'll graph it as well, but let's do the graph it. So first things first, can I plug a 0 into this guy?
Well,
Yeah.
the right design,
Huh?
No, not.
it would be undefined, right?
It would be undefined, right? You can't plug in a 0. Bummer. Okay, did you burn it? Okay. Did you burn it? No, you shouldn't.
Yes, you should.
No,
Light
you
your
don't want any
hair on
accidents
fire.
here.
But it's all of the instructions.
So let's go for it here. So we're gonna go,
Pull off a piece of hair and just like burn it into the socket. Well, the thing is, your hair wouldn't actually burn, it has to be attached to both sides. So if you took a hair out of it, I don't know how conductive your hair is. Yeah.
say again?
I was saying, probably,
Keratin-
there probably isn't not like.
Keratin's not super conductive. If you use it like how light bulbs are and you use it as a filament, then it would light on fire.
Okay.
But actually, you could be kind of weird.
So if we use your hair like a light.
Not at 1, not at 0, right?
Like 0.001.
Uh-huh. So real quick here, so let's go with it. Can you guys give me values for negative 0.1?
We didn't need to do this on
Just trying to get somewhere.
0.0175.
Divided by x. So you put in sine of x divided by x. And then you probably, as you put it into the calculator, you probably should divide like this, right? Close off the parenthesis and then divide by x. And so what you guys get for negative 0.1 on the table?
All that we use error.
Okay.
We have y equals sine of x over x through, and then on the table.
That is weird.
Minimize that.
Did you get 0.0175?
No, I'm just, I don't know how to recreate that table on the calculator.
Oh, you can,
Punch in that little. I mean, I can
Okay.
pull up the table that's like, so it's on the same page as my graph. But without creating, like the way my calculator works, it's like,
Let's keep going for us. Just remove that.
it's kind of like to pull up a table, it's like a whole different page. It's not like,
Like a new tab type deal.
it is actually a new tab. Like I have a separate tab for graphing and for calculating, it's just kind of.
No, I'm happy for you. I just,
Okay. Let's see how that works.
Sarcasm in your voice.
yeah. I don't want that plugged in because I wouldn't understand that you could sit down with that. I don't want to spend time initially.
Yeah, let me walk around. What you guys get for,
I got a line when I graphed it.
Same, I got a line. Did you get 0.1 cents?
If I zoom,
Yeah,
if I zoom
yeah,
in, you can see it's very
0.01.
slightly above,
Yes.
Yes, it is.
on the block.
Man.
You can see it's like slightly above, on the other, just-
Okay.
Okay,
It's basically the same as this.
add a widget,
Then harder than you have on
so I add a widget.
the map. You can't change the basics.
But I have a question. Is there statistics anymore, like normal statistics? Or since they're including geostats, is statistics a class anymore?
So basically not, this was supposed to be the last year, but I had no use getting it, something, but it's not happening, I was actually living it, checking out. It's,
Oh, I did it.
So wait, does that mean you don't get started?
Sorry, we're getting there. Let's see. It's getting something that I don't think that was supposed to be the case here. So as x goes to 0. Can you guys try it from the right-hand side?
So just do 0.1 instead of.
Yeah, 0.1. I just want to see what, does that give you a different answer here? Let's go with it here. So, but 0,
Same thing.
0.1.
I pressed the graph button, now it's just grabbing the line, stop it.
Okay. Can you punch in a 0.01 then?
I've never really had a good grasp on
0.01.
No, stop grabbing the line.
Same thing.
It's, yeah, it's same thing. You've never had a good grasp on graphing?
Like you go like
No,
people are
on the
doing it.
table, how do you use the table? Actually, geometry
those are
is
like
the one
harder
that
than
I don't know how to use.
Hmm.
There's just geometry tab, and it just opens up the form.
If you do
And then you can draw
1, e to the negative 5th, it's still 0.0.
like, oh,
Oh, interesting. Okay.
It changes the line, right?
hyperbole, but then like,
Okay.
how to draw that, so like,
But that would make sense. When you graph it, it's the line that is just slightly above. The x.
onto it.
Uh-huh. So,
Slightly above.
Yeah, when you graph it, it's just a line, and it takes a super long time.
yeah, let me think on B for a little bit here. How that's supposed to work here. Interesting. Okay, let's do, can we come back to B later on here?
Uh-oh.
Let's do C.
You can put Pokemon.
Widget, something.
Yeah, there's like a widget when I go to add a page. Number
Okay,
8.
It's like,
super happy.
add
it's like
widget.
apps.
Actually, well, my widget folder is
But I don't
empty or
care.
missing, so.
Hey, you know what you should do?
Yeah, it's a sign.
You should put
No.
Pokemon. You can play Pokemon Crystal on that. Actually, you can probably play Pokemon Black and White.
Our little
Okay.
problem. Old little
Yeah.
problem.
One little problem here. So whenever you,
Maybe not Black and
Oh, wait, it works.
Old problem.
whenever you do it by table,
Oh, what?
Actually, no, you could play
Weirdest
that.
graph I've ever
No,
thought
it's just that,
It's only for games. So you can play Crystal.
asymptote, right? Wait, but it'll be like, it's just an asymptote right there, isn't it?
Yeah, there's
It should be an asymptote over the
of.
sign.
Dude, that's until both.
Sign.
Yeah.
okay, so
Yeah.
We did-
What can we set the table at?
It also like.
let's see, let's start it at, sure,
As dotted line or.
Start.
0.1 is fine. Let's go from the right-hand side first.
Alright, let's see what this is. Oh,
7.1.
yeah. That.
You know, that's why. Okay, hold on. Can you guys change your, okay, totally get it now. Yeah, let's go with radian mode. That would totally help.
Radian mode? I love
Yep.
radian mode.
Because it gets you real numbers to real numbers.
0.544.
No.
Thank
I
you.
need to switch to gradient.
Okay, so let's go back. Now I figured out, sorry.
Will
For
we be
B,
using gradients?
no,
Okay, so for, it's
Sine X over X.
Yeah, sorry guys, let's go back to B to finish up, and then we'll finish up that one and that one. So this one, let's go with it. Sine of X over X. Can you guys give me as X goes to 0? So from the right-hand side, then we're going to go from the left-hand side, and then we'll start there by tomorrow or Wednesday. I need to see this right here by table.
Oh, it's 1.
Maybe we need to argue negative.
So we got to do both because we're going to do X goes to. So you did this one.
Got it. And I did negative 0.01.
Negative
1.
0.01. This one right here.
Yeah.
It's 1.
Why don't you just do negative 0.1? It's 0.99. Oh, wait. This is the different other side above. Yeah.
Okay.
I press the graph button again, stop it.
And also 1.
That also graph
Yeah.
really weird.
At that point, it's going to go to 1. Cool. All right. Can we do the positive ones?
Wait, I didn't get that.
I did 0.99.
Wait, how
Sure,
are
sure.
you getting that?
Sure. I switched back to B first of all. So it's sine of X divided by X,
Oh, okay.
and then plug it in. And this one probably the same.
0.9983.
0.9983. 0.01. You did good?
1.
Second? 1? 1. Yeah, and then 1 all the way through. So your calculator, it tries to give you the decimal expansion, right? At the same time, if it's just too close, it's just going to give you the 1. We're good?
Because at that point, you should just also write 1.
Uh-huh.
Okay.
Okay. So notice on the left-hand side, most likely it's the same here. So Kate, we good there with this one? It goes to 1?
Yeah.
By table, this one also goes to 1. Notice the exact same value. We also know that is a even function, right? When things are the same on both sides. All right, so we have this right here. We could have done it by a graph. So notice the right-hand side, and the left-hand side, they both equal each other. Therefore, the solution. Let's graph it real quick here. Can you guys graph this on your calculator? See what that looks like.
Because weird.
No, not that one.
Oh.
It's sine X over X.
Oh, never mind, that's just, no.
And then, yeah, zoom out a bit. Zoom out a bit from it. It should be a line that goes like this.
It does go like that. Why does it go like that?
Right there, right?
No, it's not the sine curve because it's only big hump is in the middle, and then the other ones are all.
Yeah, and the reason why the humps become smaller and smaller because you're moving away from X. And so the denominator gets bigger and bigger and bigger. So therefore, overall, it gets smaller and smaller and smaller, right? Right, as this X goes to 100, now it's sine divided by 100, as opposed to here, it's sine divided by 1. Okay, real quick here. Sorry, go ahead.
What about
Oh,
0?
And that's the funny thing is at 0, it would be undefined, right? F of 0 is
So
undefined.
it's just like a whole, like one of those.
It's a whole.
What?
So yeah, if I were to graph it correctly, right, it would be like this.
Oh, it's one of those where it just, oh.
Okay, there's
If I
yeah,
zoom
there's
in
a-
on this, will there be nothing there?
No, I think there'll still be there on the TI-83 calculators, the old ones. You'll see a gap like this because they calculate these ones. They're probably when a calculator does it, it just calculates stuff, and so it's a number crunching machine, right? It doesn't sort of think about what the gaps are, and so most likely it will actually just give you the line.
Yeah, I can see a line.
Yeah, I think it's a line. Okay, one thing we can connect backwards here. Do you guys remember who's the guy that measured the universe again? There's Starkus, right? Because star was in his name. You guys remember him doing this in our previous book here? It was what? Sine of.
Yes, that was what I was confused about, but he was doing a limit, right?
Yeah, he was.
Just to read his-
Good. He was saying like this, sine of pi over 6 is roughly about pi over 6,
Yeah.
right? And
Right.
sine of, right, pi. So it's roughly that. Well, that is a consequence of kind of this right here. Notice if I divide, true? Would you guys agree?
Yeah.
As long as you're very, very close to 0, right? That's the thing. As long as you're close to 0, that makes true. If you're out, then 4, yeah, if you're out way, way far, then that way. But I thought it was kind of interesting. There's a little connection there that we got from the previous textbook. Okay, so for you guys, homework-wise, since we do have to finish class sometime, right? We'll start off with a little problem next time. We'll start off with a little problem talking about it here. Can you guys do this one for me here? Can you guys find? Oh no, we'll just handle it next time. This is be D. D would be limit. Let me just write it in so I remember. 1 minus cosine of x divided by x. That would be the next one. Okay, homework-wise. Sorry, got to give you homework here, right? Got to give you something to do. I really liked 42 and 44, so I'm going to sign it. I'll give you guys the answers to it.
Is this right?
This is 2.2. So 35, 41, and 42, 44. I like those even problems. And then it's 47 to 81. But they should be really quick, though. So there's a new limit. Okay, and if you can do some of them, that's okay, because we haven't got to the very, very tail end of 2.2. At least start the homework, and we'll go from there.
I can do that.
All right. Thank you, guys. And that's it.